Hello out there again in Calculus Land. We're going to look at a problem from your homework, problem number 19. The cool thing about this problem is you can see they already gave you what u is. As you can see, u is, again, it is just the inside function, right? So we're just using, if you watched the last video, remember this is basically just the chain rule in reverse here. So it's allowing us to do that. And the u substitution, what it also does, and I didn't mention this in the last video, is that it rewrites the problem, or it allows us to rewrite the problem into something that is more simple and something that is easier for us to integrate or anti-differentiate, okay? So we're going to go ahead and make that u substitution now. So we're going to say u, we're going to plug it in here, right, for the function to see what we get. And hopefully you're going to realize the problem with that. So we get secant of u times the tangent of u dx, and then we end up with the same problem as last time. You have u's and an x here, and you have dx, right? So you cannot anti-differentiate u with respect to x. So everything needs to be as a function of u here. So we're going to use our u substitution. So we know that u is 2x here. So this is what we did last time. If you watched it, we're going to take the derivative with respect to x of both sides. So we get du dx equals 2. True? And now I'm going to multiply by dx. Why? Because after you get it in this form here, you want to separate the variables. Let me write that down. And then we'll practice doing it quickly. So what you get then from here is you get the dx is cancel, and you get du equals 2 times dx here, right? Okay, so what the practice that I want to get everyone, or I want to get everyone in the practice of the following here. So in the future, let's just say you had, let me make another problem here. Let's just say you had u is equal to, I don't know, 7x squared or whatever, right? So when you're going to, I want you to take the derivative of both sides and then automatically put the du's and dx's where they go. It'll just save you some time. So this would be du, because the derivative of this one is going to be du, and it would be over dx. You take this derivative, which would be 14x, and then just multiply times dx here. So in other words, multiply, or just eliminate, not really eliminate, but automatically put the dx here, that would have gone on the bottom of du, times the x values here. So it would just be 14x dx. It'll just save you time. Anyways, if you want to continue to do that, that's fine, but I would strongly recommend that you get into this habit here. So now what we do is we would go back to our problem and substitute in what we need. So as you can see in the problem, we do have a dx here. The dx is where? Oh, it's right here, but the problem is we don't have a 2 here. But we can correct this by multiplying it by a factor, so we're going to do that right now. So if we can see here, so in this problem we're missing a times 2 in our integral, right? Because that's what we need to plug in for du here. So I'm going to put a times 2 here. Times 2. I'm going to put it in there. You can't really see. Maybe I should rewrite it here. Let me do that. So I'm going to get, this is the antiderivative, the indefinite integral of secant of 2x, tangent of 2x, dx here. And what I want to do is I'm going to put a 2 in here. That didn't help. I just it's still crammed, but that's okay. But you notice I can't just arbitrarily put a 2 here, because that changes the problem. So what I'm going to do is I'm going to correct it. How? I'm going to multiply by 1/2. Why am I doing this? Well, because what is 1/2 times 2? They cancel out, and I'm left with just the original problem. But if I do that, I can then substitute in what du is. Du is 2 dx, and now that I have corrected it with a 2, now I can put it in. So I'm going to substitute in, so this here is du, so I'm going to plug it into my function here. So what we get here is 1/2 times the integral. Oops, and sorry, these should all be u's when I rewrote it again, right? So it should be secant of u times the tangent of u times, now it's du here, okay? Sorry. So now we have to, and now you can see it's a lot simpler to look at, because there's no inside function, and hopefully as you go through these you'll get better at recognizing them. So you have to think what derivative is secant tangent, and if you remember the trick, or the mnemonic, it's sec sectant, so it's secant. So it's going to be 1/2 times the secant of u, and then when you're anti-differentiating with an indefinite integral, you need to put plus c here, right? So just to clarify, it is 1/2 times the entire quantity, but as you know, if you distribute the 1/2 here, you get 1/2 times the secant of u plus 1/2 of c. Now remember, c is just a number. We don't know what it is. So what's 1/2 a number? It's just another number, right? So if you want, it's just, so we would call this secant of u plus c1, if you want to call it. Technically speaking, we should denote it something differently. And now we resubstitute what u was. What was u? U is just, what was u? U was what? U was 2x. So we put back here 2x. So let's say we get 1/2 of secant of 2x plus c here. And then this is our final answer here. And this is what we solved this using u substitution, and we corrected the value of du here by multiplying times a factor of 2 and then correcting it by a half. Okay, so you probably want to use this strategy in a few of the problems. The other videos will have that as well. And also, one quick thing you want to do is to, you can check your answer, which I'm going to do right now. If you don't want to check your answer, you can go ahead and pause and move on, but I'm just going to check my answer. So remember, so the idea is that the integral of secant of 2x plus, times the tangent of 2x here, dx theoretically equals 1/2 secant of 2x plus c, right? This is the theory, this is what we have concluded here. So how do we know this is true? Well, if this is true, then the derivative, if I go forward, the derivative of 1/2 of secant of 2x plus c must be equal to secant 2x times the tangent of 2x, right? So if it's correct, when I take the derivative, I should get what I was taking the integral of, right? So let's check it out. So 1/2 goes along for the ride. The derivative of secant is secant blah blah times tangent blah blah times the derivative of the blah blah, which is 2x here. The derivative of a number is always 0, so I'm going to put plus 0 here. And now I'm going to simplify. So I'm just checking my work now. So the derivative of 2x with respect to x is 2. 2 times 1/2 cancels to 1, and I'm left with secant of 2x times tangent of 2x, which is what I had in my indefinite integral here. So it was right here. See? So it actually does work out, and this is the correct answer here.